Hello and welcome back. We're going to be looking at higher maths, functions and graphs, exponential functions today. First of all, what is an exponential function? An exponential function is something of the form 7 to the power x, 2 to the power x, negative 1/2 to the power x. So rather than x to the power of something, we have a number to the power x. Now that number is always going to be greater than 0. So we wouldn't have negative 1 to the power x, for example, or negative 4 to the power x. We'd have a positive number to the power x. And here you've not done set notation yet, guys, but you will be doing that very soon. This basically means that a and x are both elements of the real numbers, so that's any number you're aware of, as long as a is greater than 0. Again, we'll cover that in about 3 or 4 lessons' time. So rather than talking about the graph just now, we'll do a quick example, then come back up to this. So example here, sketch the curve with the equation y equals 6 to the power x. So the y coordinate is equal to 6 to the power of the x coordinate. So when x is negative 1, the y coordinate will be 6 to the power negative 1, which is equal to 1/6. When x is 0, the y coordinate will be 6 to the power 0, which equals 1. When x is 1, the y coordinate will be 6 to the power 1, which is 6. When x is 2, the y coordinate will be 6 squared, which is 36. So if we plot these 4 points, we have negative 1, 1/6, which will be here. We have 0, 1, which will be here. We have 1, 6, which will be here. So the graph is getting very, very steep very quickly. And if we could fit it on, we'd have 2, 36. So that'd be 6 times as high. So that would be up right up here somewhere, wouldn't it? So it'd be getting very steep very, very quickly. Okay, so let's just go back and look at the general case now. So when x equals 0, for the graph of y, f of x equals a to the power x. When x equals 0, f of x is a to the power 0, which is 1. So these graphs are always going to cross at 0, 1. Also, when x is 1, f of x equals a to the power 1, as we've seen down here when we had 6 to the power x. When x was 1, the y coordinate, or f of x, was 6 to the power 1, which equals 6. So if it's a to the power 1, it will just be a. So here is the general exponential curve. So this will get steeper unless a is a number just over 1. It would look like this. But basically, they're always going to pass through 1 on the left-hand side here. It will hug the x-axis. And on the right-hand side, it'll get very, very steep very, very quickly. That is for values of a greater than 1. If a is between 0 and 1, then this curve essentially flips in the y-axis. It reflects in the y-axis. But anyway, it would fall very, very steeply. It would pass through 1, and then again it would hug the x-axis. So what we could say is the x-axis is an asymptote, A-S-Y-M-P-T-O-T-E, an asymptote to the curve, which is a vertical line that gets very, very close to the curve but never actually touches it. Okay, so let's have a look at number 2 here. So sketch the curve y equals 3 to the power x. So we know, or we're expected to know, that these exponential curves look like this or like this depending on a value of a. So for y equals 3 to the x, I know it's going to cross at 1. I could mark on 1, 3 here. Okay, probably should have marked that on in hindsight. And that's it, done. F of x plus 1, or y equals 3 to the power x plus 1, so that is just f of x plus 1, which is going to move the original curve 1 to the left. So at this point here, 0, 1 will move 1 to the left. So that here would be negative 1, 1. And remember, 1, 3 would have been here. So when that moves 1 to the left, that would be 0, 3. Or alternatively, we could substitute an x coordinate of 0 into here. So 3 to the 0 plus 1 would be 3 to the 1, which is 3. So we can think of it as the curve moving to the left, or just substitute in to get the intercept.